All right, in this video we're going to go over the 2009 Form B FRQ question number 1. So we're given this table with time measured in seconds and then velocity in meters per second. Question A asks us to estimate the acceleration of the particle at time t equals 36 seconds. So we know that acceleration is the rate of change of the velocity. So when we think about part A here, what they're really asking us about is A of 36, which is v prime of 36, because acceleration is the derivative of velocity. Now, because we don't have a function for velocity, we can't take the derivative of velocity. We just have this table of values here. But we have to make sure we notice that it says to estimate this value. So anytime we're asked to estimate a derivative from a table, usually what that means is pick 2 points on the table and find the slope of the line between those points, the average rate of change between those points. And so that's what we'll do. So it's time t equals 36. So all I have to do is pick any 2 points that would contain 36. The most natural way is, of course, to use the 32 to 40, because that's going to be the best estimate I can find. I could, of course, use from 0 all the way to 40 because 36 is in there. You couldn't use 0 to 8. That would be illogical because 36 is not part of that. I'll use what I think is the best estimate, which would be using this little interval here. So it's just slope. And so we say, okay, this is approximately y2, 7, minus y1, negative 4, over x2 minus x1, which are our time values in this case. And so then that's going to be 11 over 8. It says indicate units, and so that would be meters per second is my units for the 11 per second, which of course you could say is meters per second squared. But you don't have to do that simplification. You could just leave it as meters per second per second. They didn't ask for any explanation, just the computations and the units, so we've done that. Part B, using correct units, explain the meaning of this integral in the context of the problem. So I know that if I have velocity, then the definite integral represents the area underneath that, which in this case represents your displacement. So this would be your displacement on the interval from 20 to 40. Now, of course, you could describe what displacement is. It's, the change in position, the net change in position from 20 to 40, but just calling it displacement is fine. Trapezoidal sum with 3 subintervals to approximate that. So here's the chunk we're looking at from 20 to 40. So if I think about my trapezoid, each of those are going to have the area of one trapezoid is 1/2 b1 plus b2 times the height. Now when we do these trapezoid sums, we have to remember that something roughly like this, where here's b1, here's b2, and here's the height. So the b1 and the b2 are consecutive y values, and then the height is the change in the x, or in this case t values. So if I write all that out, I've got to do 3 of them. So my first one, b1 is negative, so we'll just say, let's write it out here, 1/2, b1 is negative 10, b2 is negative 8, and my height is from 20 to 25, which is a change of 5. Then do it again, 1/2, -8 plus -4, and my height this time is from 25 to 32 is 7. One more, 1/2, -4 plus 7, and from 32 to 40 is 8. Now I don't actually have to simplify that at all. I can just leave it like that. That's fine. So I think that I will. Okay. So then part C says, on this whole interval from 0 to 40, must the particle change direction in any of the subintervals? And if so, identify the subintervals and explain your reasoning. So first thing I think about here is, I know that a change in direction would happen when velocity changes sign, either from positive to negative or from negative to positive. Now, I can see that that happens a couple of times here. So here we change direction somewhere between 8 and 20. Now where exactly, I don't know. And then again, somewhere between 32 and 40, we change from a negative velocity going to the left along the x-axis to a positive velocity. So we have to change direction there. And so I would just say, part C, yes. Let's double check here what exactly they wanted me to say here. Identify the subintervals and explain your reasoning. So somewhere between 8 and 20, we change from positive to negative. So yes, between t equals 8 and t equals 20, v of t changes from positive to negative. And between, what was my other interval where we changed from negative to positive? Between 32 and 40, we change from negative to positive. Between t equals 32 and t equals 40, v of t changes from negative to positive. So we have to change, I mean, that's by definition a change of direction there. All right, part D, suppose the acceleration is positive from 0 to 8. Explain why the position of the particle must be greater than 30 meters. This is sort of a sneaky one. All I know is that the acceleration is positive. It's like, okay, why do I care that the acceleration is positive? Because if I want to know about the position, well, then usually what I'm thinking for position is, okay, if I know what the velocity is, I can then take the integral of velocity to get my displacement, add in my initial value, and then I'll know my position. Now, I don't actually have a derivative, or I'm sorry, I don't actually have an equation for velocity. All I have is this table. And so what I know is, okay, the velocity when I start is 3, and when I finish it's 5. And this is important to say that the acceleration is positive. Because if acceleration is positive, that means the slope of v of t is positive the whole time. Which tells me we can never have been less than 3 for our velocity. We had to have increased from 3 to 5. Now, it doesn't have to be a steady straight line increase, but it has to always be increasing. And what that tells me is, well, the velocity could have been 3 for almost the entire interval, and then just at the very last minute, like had a really big, like quick exponential growth almost from 3 up to 5 in that, like, last tiny little interval. But to boil all that down a little further, I know the velocity was at least 3 the entire time from 0 to 8. And if the velocity was at least 3, if the velocity was at least 3, let's go ahead and get rid of that guy. D. If a of t is greater than 0 on the interval from 0 to 8, then v of t is greater than 3 on the interval from 0 to 8, which means my displacement on the interval is at least 24. Because if we're going at least 3 meters per second for 8 seconds, that's at least 24 meters covered. And then our initial position equals 7, so 24 plus 7 equals 31. And there we go. All right, so that is number 1 from the 2009 Form B AP Calculus AB free response.